differentiate between a confidence interval and a level of significance? Confidence interval is a range of values derived from a sample that is likely to contain the true population parameter. The parameter could be mean or proportion. With a certain level of confidence. That is your confidence interval. Confidence interval. It's just like a range. You need the lower limit and the upper limit. Okay. So it all depends. Are you dealing with a population mean or population proportion? Okay. Then, so with this confidence interval, it actually tells you how much you can trust your sample result. How much you can trust your sample result. Okay, then level of significance. Level of significance. Significance. Is the probability value. Is the probability value which is used when conducting tests of hypothesis. One student can say this. Tests of hypothesis. Or you can say level of significance is basically the probability of one making an incorrect decision after the statistical testing has been done. Okay. So you can choose any, or if you have yours, you can just put any. Just write anything you know. Like the way I told you, it is like the percentage of error. This level of significance is like the percentage of error. Okay. Colleagues, confidence interval is different from confidence level. Those things are different. Confidence level is how confident are you? That is like the percentage of accuracy. Confidence level. But interval, when it comes to interval, you're looking at the range of values. Lower limit, upper limit, the range of values. Your population mean can be in between the range of those values. Okay. So next part Roman 2. I'll try any two differences between the normal distribution and the, do you know them? Eh? Do you know them?
No.
Okay. So what you can how do you understand the T distribution? How do you understand the normal distribution? You can relate and come up with the differences. Okay. So maybe you can write and say one.
It's better than that.
Normal distribution is applied where n is large. Okay, where n is greater or equal to 30. Greater or equal to 30. While T distribution is applied where n sample size is below 30. Where n is below 30. Okay. Plus any other. So that's all. Then next. The scores of 5 students for an interview at Koremu Limited were recorded during an interview done by Mr. Saf. Scores, you have these. Determine the confidence interval for the scores of the whole class at 5% level of significance, given that the scores are normally distributed. But are you seeing this? Determine the confidence interval. Here you are not testing. You are looking for the range of values, the upper limit and the lower limit. Okay? So we are given from the question, we have 5 students. We have 5 students and their corresponding scores. We have 5 students and their corresponding scores. So what is going to happen? You're going to say that
That means
let X be the scores of the students. Okay. Let this is question what? This is question 3. So from here, we are given sample size n. N is equal to what? N is 5. Sample size. Then you have the scores. You have the scores. You have the level of significance. Now, are you going to use Z test or you're going to use T test?
we use t-test.
The sample is below 30. Okay. So using the t-test, my population mean, that is new, should be equal to, do you remember the formula? The confidence interval. Do you remember the formula? You have the x bar, the sample mean. You have the x bar minus
Plus
O plus 5.
T times SP.
minus O plus. We are going to use T because this is T test. T alpha. T alpha. Let me just say T alpha. Let me just use what? Let me just use this. Then times what? Times what? Times standard error. Times standard error. Where standard error is equal to what?
S over square root of N.
See, standard error is equal to
We
Can
can
you-
get the mean.
Can you
We
get
can get the mean.
the sample mean?
Some-
For me,
4.
sample mean, that is X bar. Oh. Open. So X bar is equal to, we get
Summation.
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 Summation what?
85 plus 75 plus
85
Summation.
plus 70.
Summation X over N. So you add all the figures, all the values of X, all the scores. We have what and what? Tell me. The first one is what?
85.
85 plus
75.
75 plus
65.
65.
Yeah.
Then plus
80.
100 plus.
Plus 90.
Then everything divided by the N, which is 5. What do you get?
79.
70. Someone is saying 79, 78. Which one is which?
79.
79. Can you get the standard deviation? S is standard deviation. How do you get standard deviation?
X minus X bar.
Standard deviation.
Summation.
Standard deviation.
Square root.
That is S. Sample standard deviation is equal to the square root. Of course, here it means that you will need to come up with a table. You need to come up with a table. A table showing what and what. You will have X. We have 85. 85. You have 75. You have 65. You have 80. You have 90. Okay. Then from that, you will need X minus mini bar.
That is supposed to be squared, the formula.
The formula is supposed to be squared.
Yeah, yes, standard deviation.
This one must be squared. Okay, so I don't need this. So substitute, already you have X bar. So get your open bracket, get 85 minus what? What was our mean? Our mean is 79. So get 85, open bracket, 85 minus 79. close bracket, then squared. What do you get? Or you do and tell me the answer. Do everything and tell me the answer. Here you have 6. I don't know what you have.
If we square
36.
You have 36. Oh, yeah. 36. 36. Just tell me I want the answer, the final answer. This is 75, open bracket, 75 minus 79, close bracket squared. That is it 16? Yeah, 16. 65. Standard deviation will be equal to, it will be equal to the square root. It will be equal to the square root of 379 over, what is n? N is 5 minus 1. What do you get? This will be square root of what? 370 over 4. The final, just tell me the final answer.
92.5.
That is square root.
Yes. No, wait.
This is 370 divided by 4. You get it. We need square root of actually that figure. We need square root of 92.5. What do you get?
9.6177.
So it is 9.6.
177.
Okay. So substitute now, you have everything. Okay, do we have everything? We have do we have this? We can get from T table. How can we get this? Remember, recall. Recall that V is equal to what? N minus 1, which will be 5. 5 minus 1, you get 4. Okay. The level of significance from the question, level of significance is what? Which percentage? Which percentage? What is the percentage given? We are given 5%.
Hey.
If you're given 95%, you change. So we are given 5%. And I told you, whenever you're dealing with confidence interval, automatically that is two-sided. Okay, so it will be 0.05 divided by 2. What do you get? That is 0.025. 0.025. And because you're dealing with t-test, you don't need to say 0.5 minus this. No, that's all. Just go to your table and read. What is this? What is this value? This one will be equal to, from the table, from T table. Stand where you have V, move and check the column for this. Let me open. Past paper question.
1.8.
I believe you guys, you're done. I believe you have the table. You'll be given the table in the question.
Seven.
Which screen are you seeing? So here is our, this is our view. We are looking for 4. This is 4. Then column where you have 0.025. It's this. So it is. Do you have? Do you have 2.776?
Yes.
Yes.
So it is 2.776. Okay. So substitute in your formula. Substitute in your formula. And this will be what? This will be.
You're looking for?
What is mean? Mean
You
is
first to announce that I don't.
29.
minus O plus. We have this 2.776. Then times what was our standard error? We didn't do the standard error. So what is our standard error? Our standard error. So from here, our standard error would be, our standard error would be what? 9.66177 over root n, over root 5. Over root 5. The final answer? This is 9.6177 divided by root 5. Do you have 4.3? 4.301. So that is your standard error. This is our standard error. Okay. So you substitute 4.301. So finally, your population mean. Your population mean should be equal to 79 less or equal to 79 less or equal to. If you multiply what? 2.776 times that is 11.9396. So finally, you can say that the population, the lower limit, the lower limit is what? And the upper limit is what? The lower limit will be, you get this 79, then minus this. Then upper limit, you add. You get that 79 plus, get 79 plus. Here, what do you get? So the 79 minus answer, that is 67.06. Then here it will be. That will be 90.9396. 93. So finally, to conclude, you can say the population mean is in between the population mean or the confidence interval. The confidence interval is you start with lower limit is this the score. So you can find your population mean is in between this. Your population mean can be this or can be this, or can be in between. Can be in between these values. So that is the answer. Any question? We are done with that. Next. Which screen are you seeing? The question paper?
Yes.
Okay, so they are telling us that in a random sample of 100 persons, taken from village A, 60 are found to be consuming tea. Okay, so you have this is question what? This is question what? Question 3 what? Part C. You have anyone?
Yeah.
Anyone as what? Anyone as
100.
100. Then the probability of success, the P is what?
60.
They are telling you that 60 are found to be consuming tea. So out of 100, 60 are found to be consuming tea. So that is you get. But before you say that 60 is P, always first look at the required part. Is it talking about those consuming tea or yeah? So that will be the probability of success. So 60 over 100, that is your P. That is 60 over 100. So it means that this is 0 0.6. That is P1. This is P1. So it means that here Q1 is equal to what? Q1 is equal to what? 0.4. In the next sample is how many? Next sample, how many? In another sample,
200.
Village B, 100 persons are found to be consuming tea. This is 200. This is village A. This is village A. This is village Village B. So what is the probability of success?
0.5.
100
over 2.
100 over 200. What do you get? 0.5?
0.5.
0.5. Then what will be your Q2?
0.5.
0.5. Q2 will be 0.5. Okay. So once you have this, they need what? They need this, you need to test at 5%. Do the data reveal significant difference? Now, whenever you're testing a difference, that is two-tailed test. Whenever you're testing the difference, you don't know the difference. So that is two-tailed test. You have to start with the state the hypothesis. State the hypothesis. The first thing. What is your H naught? There is no difference. There is no difference. There is no difference between, or there is no significance difference between there is no significant difference between this and number 2. The opposite. The opposite of this is what? There is a significance. There is a significant. There is a significant. There is a significant difference between. Okay. Whenever you're testing the difference. Okay. Next. Test now. Here we state the hypothesis. Now test. Test your hypothesis. Test the hypothesis. Test the hypothesis. You need the computed value. You need the value from the table. What is the value? What is the value from the table? Are you using t-test or you're using z-test? What is the value of z? Because anyone -2, you see that if you get anyone, you use z-test. If you get any1 plus any2 minus 2 and you get the answer which is below 30, you use t-test. So here we are using z. What is the z value from the table? Remember, we are testing here at what? How do we get the z value from the table?
We get
What is our level of significance?
X bar
5%.
5%. Remember, this is two-tailed. You're testing a difference. This is two-tailed. So level of significance is equal to 5% divided by 2, two-tailed, which is 0.025, isn't it? However, we are using z, so z table you get 0.5 minus 0.025. What do you get?
0.475.
0.475. This is the probability. This is a probability. This is the probability of Z. Probability of Z. But we need Z. So what is Z value? So what is the Z value? Which Z value gives us this probability from the table? So what is the Z value? Z value is equal to what? From the table. From the table. You have been doing this several times.
96.
1.96.
I believe by now at least. This is Z. This is Z table. So we are looking for 0.75. 0.75. These are probabilities. Where do you have 0.75? It is here. Here. So which value gives you this probability? It is 1.9.
1.96.
1.9. Which column? 1.96.
6.
Here it is 1.96. Now you have the value from the table. The question is, what is the computed? Find the computed value of Z is equal to what? Who can recall the formula?
X bar 1 minus X bar 2.
Divided by the standard divided by the standard error. But standard error is equal to what?
The square root of
Square root of
2
P1.
over N1. P2 over
You
N1.
do and tell me just the final answer.
I do.
You do and tell me the final answer of standard error. All of you.
We are together. After we convert P1 and P1 and P2 into P. It is a long process.
Now, colleagues, we have two approaches, and I believe sometimes examiner can examiners can take you off, but you can get P1. Okay, you can get P1. I told you get Q1, P1, Q1 over N1 plus Q P1, rather P2, Q2 over N2. But when you meet this formula, don't be surprised. So what is your P? Substitute, you have everything. You have everything. What is your P1? Your P1 is from above. Your P1 is 0.6. This is 0.6 times N1 100 plus 200. Your P2 is what? P2 is 0.5 times N2 is 200. Then everything over N1 100 plus 200.
Is 0.5.
You get 0.53. 53. So it means that your Q will be equal to 1 minus P. which will be equal to 1 minus 0.553. What do you get? Let me hope you have used your calculator very well.
Yes.
Those who are just copying. So once you have this, substitute. What? N1 is
When I-
100. Then this one is 0.53 times 0.47 over what? Over 200. What do you get as your standard error? So open bracket, 0.53 times 0.47, close bracket, divided by 100, equal signs, plus open bracket, another bracket, 0.53 times 0.47, divided by 200, close bracket, equals square root of answer. Well, you have this 0.0061.
Zero.
That's what you have.
Yes.
Okay, so that is your standard error. Remember, we need the computed value. So the computed value, 0.6 minus 0.5 plus bracket divided by answer. 1 point what? 1.64.
Yeah.
1. Remember from the table how many decimal points? 2. So it is 1.4. So compare the value, the computed value with the value from the table. Are you going to accept or reject? Now conclusion.
Going to
Conclusion.
we add-
Conclusion, are we accepting? Since
Yes.
the computed value, since the computed value,
False.
you see the computed value, is it greater? If it is greater, we reject now.
Is less.
Since the computed value is less, since the computed value in the bracket is 1.64, is it 64? Yeah, is less than the value from the table. From the table, that is 1.96. What should we do? And now hypothesis, accept null hypothesis. And reject alternative hypothesis. Therefore, conclude with what? With what you have accepted. You have accepted the null. So therefore, you bring what was your null. Therefore, there is no. Therefore, there is no significant. There is no significant.
Difference.
There is no significant. There is no significant difference between the two villages. Okay. That is all. Please take note if If computed value is greater than value from the table, accept reject null hypothesis, because it will be outside the acceptance region. Okay, accept the null hypothesis and reject the null hypothesis and accept the alternative. That is, if the computed value is greater than the value from the table, reject null and accept the alternative. Then if the computed value is less than the value from the table, less than the value from the table, accept null hypothesis and reject the alternative. So colleagues, that's all for this question. That's all for this question.